Welcome back friends. Today we are going to see some examples of subject space flight mechanics. So our first question is calculate the velocity of a artificial satellite orbiting the earth in a circular orbit at an altitude of 200 km above the earth's surface. Remember the altitude is given as 200 km above the earth's surface. So let us move to the solution. From basic constants, we know that the radius of the earth is 6378.14 km and the mass of the earth is 5.972 into 10 to the power 24 kg. The gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kg square, and it is given that the satellite is orbiting at an altitude of 1200 km above the earth's surface. So the radius we are going to take here is radius of earth plus the 200 km. So therefore our effective radius r is 6378.14 plus 200 into 1000, which is equals to 6578140 meter. So the orbital velocity is given by v is equals to under root of gm by r. By substituting the values for gm and r, we will get the velocity as 7781.6422 meter per second. This is our final answer. Now we will move on to the next problem. Our next problem for today is an artificial Earth satellite is in an elliptical orbit, which brings it to an altitude of 250 km at perigee and out to an altitude of 500 km at apogee. Calculate the velocity of satellite at both perigee and apogee. So let's move to the solution. It is given that radius of perigee is equals to radius of the earth plus the nearest distance. Perigee is the nearest distance from the surface of the earth. So the smaller one will be our perigee. So the radius of perigee is radius of earth plus 250. So which is equals to 6628140 meter. Similarly, the radius of apogee will be 6378.14 plus 500 into 1000, so to convert it into meters. So it is 6878140 meter, and we have gravitational constant as 6.67 into 10 to the power minus 11 Newton meter square per kg square, and we know that the mass of the earth is 5.972 into 10 to the power 24 kg. So to calculate the velocity at perigee, we have the formula Vp is equals to under root of 2gm Ra upon Rp in the bracket Ra plus Rp. Here Ra is the radius of apogee and Rp is the radius of perigee. Now substituting the values for all the constants, we have Vp is equals to 7823.6535 meter per second. Similarly, we are going to calculate the value for velocity at apogee. So velocity at apogee is given by under root of 2 times of gm rp upon Ra in the bracket Ra plus Rp. Again here Ra and Rp are the radius at apogee and radius at perigee. So substituting the values for gm, Rp and Ra, we will get the velocity at apogee, which is equals to 7539.286 meter per second. So this is our final answer. Now let's move to the next problem. Our next problem for today is A satellite in Earth orbit has a semi-major axis of 6,700 km at an eccentricity of 0.01. We have to calculate the satellite's altitude at both perigee and apogee. This is a very simple problem. So let's move to the solution. It is given that the semi-major axis is 6700 km and the eccentricity is given as 0.01. So first of all, we have to calculate the radius of perigee and radius of apogee. After calculating the radius, we can calculate the altitude of both. So let's calculate the radius of perigee first. Radius of perigee RP is equals to A, that is the semi-major axis, into 1 minus E. So radius of perigee is equals to 6700 into 1 minus 0.01. So radius of perigee we obtained is 6633 km. Now we can calculate the altitude of perigee by subtracting the radius of perigee with the radius of the earth. As we know that the radius of the earth is 6378.14 km, so we can simply subtract it from the radius of perigee. So altitude of perigee will be radius of perigee minus radius of earth, which is equals to 6633 minus 6378.14, which is equals to 254.9 km. Similarly, we will calculate the radius of apogee. Remember, apogee is the farthest distance. So therefore, in this case, we are going to add eccentricity to 1. So radius of apogee is equals to A into 1 plus E. So substituting the values, we get radius of apogee as 6767 km. And similarly, we can calculate the altitude of apogee as we calculated the altitude of perigee in previous case. So altitude of perigee is equals to altitude of apogee is equals to 6767 minus 6378.14, which is equals to 388.9 km. So that's it. This is the final solution of the problem. Friends, subscribe to our channel for more videos. We will be uploading more videos related to this topic. Stay tuned with us.